Now in algebraic fraction, we will do the factorizing denominator kind of questions. Here I have 1 over x square minus 4 plus 3 over x plus 2. This is the expression I have. So I cannot do the addition between these two fractions directly because the denominators are not same. I have to find the common denominator for them. Before that, look at this. This is having a square values. Both are perfect square numbers. You should do the factorization first. That is the important task. We will do that. 1 over, I can write the x square minus 4. Both are square values. In between we have, look at this. I will do the factorization for this here. X square minus 4. We can write this one as x square minus 2 square. You can express 4 as a 2 square. Both are having square. In between we have a minus mark. So you can do the factorization like this. X minus 2 times x plus 2. This would be the factorization of it. So I can write x minus 2 times x plus 2 in denominator plus in here we have 3 over x plus 2. Hereafter you should find the LCM for these two denominators. You cannot find the LCM for both of them directly because you can factorize this one. There is a possibility to factorize. You should do that one as the first thing before finding the LCM. After factorization, we do not have anything further than this to factorize. So in this case, you can find the LCM for denominator. In one, I have x minus 2 times x plus 2. In another one, I have only x plus 2. First, I will divide both of them by using x plus 2. So both are having x plus 2 quantities. No, both are divisible. In here, we have the remaining as x minus 2, comma, x plus 2 divided by x plus 2. That will give you 1. Then you should use x minus 2. X minus 2 divided by x minus 2, 1, comma, 1. Now we got the LCM as x plus 2 times x minus 2. X plus 2 times x minus 2. I'll write the LCM here. Look at the first fraction that is already having the LCM itself. So no need to change this one again because already what we need was we have to get the common denominator to do the addition between fractions. So this is already having the relevant value in the denominator. No. So no need to convert that. What you should do here was you should convert the second fraction only. This is already having x plus 2 quantity. It needs another x minus 2. So I'll multiply second fraction only by x minus 2 to obtain the equivalent fraction. Now both denominators are same. I'll write that x minus 2 times x plus 2. In numerator, this is only having 1 plus this is having 3 times x minus 2. So 3 times x, that is 3x. 3 times negative 2, it would be negative 6. Finally, only we have x quantity as 3x. 1 minus 6, it will become negative 5. In numerator, x minus 2 times x plus 2. This is what we have finally. This would be the correct final answer. I'll repeat from the beginning as a quick recap. Look at these two fractions. Both are having different denominators. So you should find the LCM. Before that, there is a possibility to factorize the first denominator. Since both are having perfect square, in between we have a negative direction. So it can be factorized as x square minus 2 square, x minus 2 times x plus 2. That's what denoted over here. Thereafter, you should find the LCM for both of these denominators. That would be x minus 2 times x plus 2. First fraction already having that particular denominator itself. So second fraction, it would be multiplied with x minus 2 to achieve the common denominator. Then in numerator we have 1 plus 3x plus 3x 3 times negative 2, it's negative 6. So 3x, that remains same. 1 minus 6, it will become negative 5. That would be the final answer for the question. Yeah. Question in the left, we can factorize this denominator, y square minus 16. So it can be factorized as y square minus 4 square. So it would be y minus 4 times y plus 4. That would be the factorization of first fraction's denominator. I will write that. In numerator we have y minus 7. In denominator we have y minus 4 times y plus 4. And thereafter, look at the second fraction, that is only having y minus 4. So the LCM, that will become y minus 4 times y plus 4. Y minus 4 times y plus 4. So this fraction, it would be multiplied with another y plus 4 expression. Y plus 4 expression. I'll denote that over here. Thereafter, it will become y minus 4 times y plus 4, 3 times y plus 4 in the numerator as well. So then I'll do the operation between numerators, y minus 7, and it will become negative 3 times y, negative 3y, negative 3 times positive 4, it is negative 12. In denominator we have this one. I'll use instead of this simple d letter. Then it will become y minus 3y, negative 3y, negative 7 and negative 12, that will become negative 19. Denominator we have y minus 4 times y plus 4. That would be the answer for question on left. And in the question on right, this is L plus 1 only. Look at this denominator. We can factorize this one, L square minus 1. So you can write it as L square minus 1 as 1 square. So factorization would be L minus 1 times L plus 1. So it will become plus 5. L minus 1 times L plus 1. Look at the first fraction, that does not have any L plus 1 itself. So it should be multiplied with an L plus 1 expression. So 5 times L plus 1. In denominator we have L minus 1 times L plus 1. Now let's expand the numerators. 5 times L, it will 5L plus 5. 5L plus 5. Both 1 and L should be multiplied with 5. Thereafter we have a negative direction. So you should multiply both the interior values by negative. Negative 6L and negative times positive 5, it's negative 5 over denominator. Positive 5 and negative 5 will become 0. 5L minus 6L, that will become negative 1L. Negative 1L or negative L. You can write negative 1L or negative L. Both are correct. In denominator we will have L minus 1 times L plus 1. That would be the answer for second fraction.